Hello, everyone. Good morning. And yeah, good to see you all here. I know it is very difficult to get up early in the morning, but you have taken the first step to wake up early in the morning and join this call. And whether you are looking for a new job, or if you are looking for a job switch, or if you are just trying to enhance your existing skills, let me tell you one thing. If you attend all these 3 days, right, and if you follow whatever I tell you, each and every step, then you will be one step closer to your goal. And you are unlike 90% of the people, 90% of the students who just imagine landing a high-paying IT job without taking any action. So yes, you are an action taker, and you have taken the first step to land a very high paying IT job. So, in this overall session, right, across the 3 days, I will cover majorly on the basic aspects of the software testing, and then I will also cover different things related to the resume, and then we'll also do some hands on related to the software testing. Okay, so I'll talk about each one of them, right? Day one, day two, and day three, all the details in the upcoming slides. All right. So before getting started, let me give a brief introduction about myself. Okay. My name is Prashant Nayak, and I completed my engineering in the year 2008 in the field of computer science. And I have overall 15 plus years of IT experience, and I have worked on various projects in India as well as in the USA. So regarding my work experience, right? So I started my career as a manual tester, and then I quickly transitioned to automation testing, wherein I worked on different automation tools like QTP, UFT, and then worked on the tools like Xperia Test for mobile, which is basically used for the mobile automation. And then I worked on Selenium with Java. So majorly on the experience part, right, for the automation, my major work experience is on Selenium with Java. And then after working on the automation projects, I enhanced my skill set. I started working on the performance projects as well. Uh, when I say performance projects, it's basically related to the performance testing. And as part of the performance testing projects, I worked on different tools like LoadRunner, and then we have NeoLoad tool, and then I worked on JMeter, Apache JMeter as well. So out of these three tools, right, LoadRunner and NeoLoad, they are the licensed tool, and Apache JMeter tool is the open source tool which is available free to use for any of the project. So Apache JMeter is very popular in the IT industry for the performance testing. So I worked for around 6 to 7 years on performance testing, and that was a changing point in my career. So when I switched my career to performance testing, right, my monthly income increased to six figures per month. So that was like a turning point for me in my career when I learned performance testing and then started doing performance testing. So overall, like from manual testing to automation to performance. So and that transition led me where I am right now. And again, I started my career as a manual tester, and that's the starting point, because unless until you understand right what exactly the manual testing is, the basic concepts of manual testing, different things that we do as part of manual testing, and again, the activities that are performed as manual testing, like understanding the requirement and then creating the scenarios, creating test cases, and then execution of the test cases, and understanding the functionality, how exactly we need to report the functionality, and then uh, understanding of how do we send the report to the client, and all those stuff, right? That plays a immense role when you progress in your career. As and again, manual testing was the starting point for me. It gave me the starting uh, point to get started with the IT career. So overall, this transition helped me, and this is where I am right now, earning six figures per month. So and that's about the professional career in terms of technology. And apart from that, I am part of the interview panel, wherein I take technical as well as managerial rounds for the company. And then, as part of the technical, right, I am involved in evaluating the candidates on the basis of manual testing, automation, as well as performance testing. And the main role, right? What I play is understand like shortlisting the resume, and then evaluating the candidate by taking the interview and selecting the candidates. So as being part of this interview panel, I know ins and out about what exactly is needed in the software industry and what exactly employers look for in the candidate when they go ahead and select the candidate. So that's again is a plus point, and that's something that I'll be teaching you in these 3 days on the when we talk about the resume uh, session, right? So we'll understand what exactly we need to include in the resume and what all things we should do and what all things we should not do when we create a resume. All right. Okay. So moving ahead. All right. So if you guys remember, I shared one link yesterday on the Facebook group uh, regarding the Facebook group on the uh, WhatsApp group. So that's a private Facebook group, and I request all of you to join that Facebook group. Reason being, that is the group that we will use to share the assignment solutions and all. So across these 3 days, I'll be giving some assignments as well, so that you understand the concept in detail. And once the assignments are done, right, I request you to submit those assignments on the Facebook group, and we have pretty good members in that group. So what we can do, right, we can have a look at look at the assignment. We can understand how exactly the other students are thinking when they solve the problem, because not each one of you will think exactly the same way. Because when we talk about the manual testing, right, it is more about the analytical part to understand. Like let's say I give you a application and I ask you to write a uh, test case. Okay, a person A might write test case in a different way. A person B might come up with another scenario for writing the test case. Okay, so understanding, like going through each and every assignment that students submit, right, you will get a fair idea of their point of view as well, and you can understand, you can learn more from others. Okay, so that's the reason why I encourage you to join the Facebook group and share your assignments there once it is ready. And again, in case, let's say someone has any question, right, on the QA concept, or let's say something related to the resume, then if you have answer, even if you don't have answer, you can do the research and then reply to them. That way, you will also get an opportunity to learn new things. When you help others, right, majority of the time, it will help you if you try to help others, because you tend to go in depth on that specific question and try to learn more about that specific topic. All right. And the third thing, which is a advantage of joining the Facebook group, let's say someone has got information about the job opening somewhere, or if there is a specific job fair going on, and then that person can post it on the group so that everyone is aware of it, and then they can help each other to get the job. Okay. Yeah. And again, if you guys, what I'll be doing, right, after this call today, I'll be sharing the link as well on the chat again, on the WhatsApp chat, so that in case you missed the link yesterday, you can join it today. All right. So let's understand what exactly are we going to cover in these 3 days. Okay. So today is day one. And what I'll be doing is I'll be talking about how exactly the IT project works, so that you get in and out of how exactly the IT company works, right? When I talk about the IT project, I'm talking about the individual project within the company, not and I'm not talking about the overall organizational structure. I'm talking about how exactly IT company works and how exactly each and individual project within the IT company works. So that's something I'll be talking about. And then apart from that, I'll be talking majorly about the software testing concepts, wherein I'll get started with the terminologies that we use in the company uh, related to the software testing, wherein I'll talk about what exactly is the vendor, and then client, project, and then different aspects of software testing. I'll talk about that, and then I'll get started with the high levels of software testing and different types of software testing. So the basics, right, about the software testing will be covered here as part of day one. And again, one more thing I just wanted to add you as part of the bonus. If you remember, I had asked on the WhatsApp chat saying that if you guys want to learn performance testing basics, and I got yes from many of you, and that is the reason why I decided to include performance testing basics as part of day one. So once we are done with how the project works and then basic concepts of the manual software testing, I will jump and deep dive into performance testing basic concepts as well to understand the basics of performance testing, why we do it, and what are the different types of performance testing that is currently being done and how exactly that works. Okay, so that's what we are going to do today. And then tomorrow, day two, okay, so we'll go more into technical part to understand like how exactly requirements document looks like. We'll go through a sample requirement document and then we'll create a test case, test scenario. And based on the test scenario, we'll create test cases and then we will execute the test case during the hands-on session tomorrow. And once that is done, right, so for every project, when we do the execution, software QA finds a defect. Okay, so I'll explain what exactly defect mean today. But when we find a defect, right, it has to be reported to the developer. So we'll talk about that process as well. We'll talk about what exactly needs to be included as part of the defect report. And once the execution is done, uh, the role of a software tester is to send out a execution summary to the stakeholder. So again, as part of that process, I will talk about how exactly execution summary should look like. I will give a sample report as well that you can use in your assignment. And again, if you are going to, if you get a job, right, you can use these samples, the one which I'll be sharing with you, the templates that I'll be sharing with you tomorrow. You can use them as a plug and play and get started right away in your project. Okay. So that's something that we'll be covering as part of day two. And then as part of day three, we'll talk about portfolio creation. Okay. We'll understand how to create a portfolio, the structure and all the stuff, and how to organize the artifacts that you have created in day two. So that's something we'll be doing. And then we'll understand the effective resume template. We'll understand what are the different components of the resume that is important when we draft a resume, right? There are certain things that needs to be considered so that it becomes very effective. If someone uh, goes through your resume, right, looking at the resume, they should have like all the information that is needed right on the first page. So we'll talk about it tomorrow, and then we'll have a workshop as well on the resume creation. Okay, and again, as part of the bonus for day three, what I'll be doing, right, as I mentioned on the WhatsApp chat group, will be I'll be reviewing your resume. So depending on the time constraint, so for now, like we have decided, we'll randomly pick two resumes that I have received. Okay, so depending on the time constraint, if there is time available, then maybe we can go with 3 or 4 or 5 resumes review. Okay, so that we can decide on tomorrow. But that's something that is coming up for not tomorrow, day after tomorrow. That's something which is coming up for Sunday. Okay, and again, day three, very important because that's something which is very crucial. Because the thing is, when you apply for a job, right, the first thing that recruiter sees is your resume. If your resume is not good, no matter what kind of technical information or what kind of knowledge you have on the manual testing or performance testing, your resume will not go through for the further processing. So that is very important. Having a strong portfolio, having a good resume, having a attractive resume is very important so that you get a job. And that is the first step for getting a job. So day three, very important. Do not miss it. Yeah. So that's what we are going to cover in these 3 days, and it is going to be value packed. So I suggest you attend each and every day so that you can get the knowledge that I'll be sharing. And again, it won't be just like knowledge, just like theoretical knowledge. I'll be talking in terms of my experience working in the IT project, do's and don'ts. I know what exactly works, what doesn't work. So be here and get all the information that is needed. And I'm sure, like, if you follow these 3 steps, right, you will be one step closer to your goal. All right. So moving ahead, right? So software testing skills, right? It is like currently in a very high demand. It's in high demand in the market right now. And if you think about software testing, or if you think about a company, right? Software company. So software company develops a software, right? And there are different companies who consumes those softwares, right? Like let's take an example of Citibank. Citibank has got a banking software that has been developed by a software company. Okay, or they might have a inbuilt uh, team that builds the software for them. Okay, so what happens, right? Whenever any company or any organization or anyone develops a software, before launching it in the market, it has to be tested. It is very important. Testing part is very important because you do not want someone to launch, like let's say you own a company, right, for a software company, and you develop a software. You do not want to launch the software and then realize that the software is full of bugs. It will be a big failure. Okay, so to overcome that issue, software testing has to be done before launching the product in the market. Okay, so that is the reason why software testing skills are in very high demand. And each and every company, if you look outside, whatever companies you are interacting with, each and every company is using one kind of software or the other. Okay, so there are like billions of softwares available in the market, and that is the reason like software testing skill is in very high demand. And if you look at the market, based on the Glassdoor.com, where this research was done recently. And again, Glassdoor.com is a company which tracks the uh, salary uh, of the employees, depending like it based on the area wise. Okay, so this is something that I pulled for the India region. Okay, and based on the Glassdoor.com, the average salary for software QA engineer, and again, this is for the beginner. Okay, and not someone with like 15, 20, 30 years of experience. This is someone who is just getting started. Okay, so based on this specific research, the average salary for the software QA engineer is 6,72,500 per year, and that is in India. Okay, that is the average salary. But again, that depends on the company. The range for the salary, right? It depends from like 4 lakhs to 9 lakhs. So that's the average salary for a software engineer right now, uh, based on the correct market situation. But yeah, I have seen like many of the organization, they pay somewhere around like 6 to 7 lakhs. I'm talking about a good company, okay, and not a small company, but a good company that knows that this skill is something which is very valuable. They pay somewhere around like 6 to 7 lakhs per year on an average. Again, I regarding the performance testing, I mentioned about the performance testing as part of my experience. Okay, and that is the reason why I am covering it here. Performance testing is needed again the same way manual testing is needed for the software. Uh, Similar reason, performance testing is also needed because let's take an example of Gmail. Okay, Gmail is being used by billions of users every day. What happens, right? Let's say all the users are trying to access the software, the Gmail app on the mobile, and let's say the performance is very bad, and the app is not loading, or if you are trying to send an email, the email is not getting sent, or if you're trying to retrieve an email, if someone is sending you an email but you are not able to receive an email because there is a performance issue in the application, the server is not able to handle billions of users that is expected. Okay, so in that case, right, what happens, the uh, company, right, uh, uh, people will stop using the software because it is not responding properly. They are not getting what exactly they are expecting from the software. They'll stop using it. They'll be frustrated, and then company will suffer a loss because of that. So that is the reason why again performance testing is very important for any application. And nowadays, like each and every company right now, if you see, every software has got a very high demand in the market. Everyone is using software, as I mentioned earlier. So that is the reason why performance testing of a software is also equally important. And again, performance testing is in very high demand. Again, if you go and Google, right, is performance testing in demand, it will tell you like it is in a very high demand. And again, the skill set, right, that is needed, very few employees has got that skill set for the performance testing, and that is the reason why the performance testing with high demand and very less people having that skill set, it pays a lot more money compared to the manual software testing. And again, if you look at the Glassdoor, right, the average salary for performance test engineer, again for the beginner, I'm talking about the beginner, is 7,92,288 per year. So that is the average salary for the performance test engineer. Okay, and again, I'll talk about performance testing concepts as well in today's session once we are done with the manual concepts. But again, just wanted to let you know that this is also something which is in very high demand and you should consider. So moving ahead, and just one thing I just wanted to let you know, okay, so if you guys have any question, okay, so there is a Q&A tab. Just feel free to ping me on that chat. I'm reading your chat, so I should be able to have in case you have any question. And then if you have any specific thing, just raise your hand. I think Ravi Teja has raised her hand or his hand, sorry for that. So in case you have any question, just add it in the Q&A. Again, Samir, if you have any question, just add it in the Q&A. Okay. All right. Okay, so let's get started with the terminologies. Okay, for the of the software testing, and these are something which is very important for you to understand, because these terminologies that I'm going to talk in this session, it will help you a long way. Like if you understand this, you will it will help you understand what exactly we need to do in day 2, day 3, and then during the interview also, right? These are the terminologies which are commonly asked uh, for the beginners to the beginners. So that's something which is very important for you to understand on the terminologies. So what exactly is the project? The first thing is project. So based on the definition, right? Project is a task undertaken to create a unique project, product, service, or result characterized by a set of specific objectives. Okay. So what happens, right? Let's take an example of Gmail application. Okay. So Gmail is owned by Google. So let's say Google comes to me, and I'm a software company that provides software services like software testing. Okay, so Google comes to me, and Google tells me that this is the Gmail software and I want you to test it. Okay, the goal of this testing should be to make sure it is free of defect and it is performing very well. Okay, so Google gave me an assignment. Google gave me something to work on. Okay, so that specific thing, right? Like the testing part, the testing of the project, making sure that it is free of defect and making sure it is performant. So that specific task is called a project. Okay. And then client. A client refers to an individual, group, or entity that uses the service, expertise, or products provided by another individual, group, or entity. So in this case, right? So so Google is providing me. Google is providing me with the work. Google is providing me with the project, and Google is using my service. Okay. So for me, Google is my client. Okay. And again, when we talk about the vendor, so for Google, I'm the vendor. So vendor refers to an individual, group, or entity that sells goods, services, or products to client. So I am selling my software testing service to Google. So I'll be vendor to my client. Okay. So this software testing service, right, uh, or the task that I'll be doing on the Gmail, that will be called as project. Google will be my client and I will be the vendor of Google. Okay. So moving ahead, so we'll talk about requirements. So requirements refer to document descriptions of the capabilities, features, functionalities, or qualities that a system, product, service, or process must possess. Okay. So again, let's take an example of Gmail application. Okay. So what happens, right? Gmail has got certain set of features, and Google comes to me and tells me that these are the set of features that you need to test. Like there should be inbox, there should be sent item, there should be outbox in the Gmail application. And then when there can be another requirement that says when the user clicks on compose button, a specific window should be displayed with the field to, from, and subject and body along with the send button. That can be another requirement. Then there can be another requirement that says when the user enters all the details in the compose form, and the user clicks on send, email should be sent to the person mentioned in the to field. That can be another requirement. And then if user selects the specific email and clicks on delete, email should be deleted from the user inbox. Okay, so these are the requirements. So this is called the requirement, like specific feature or functionality or the qualities, right? The application must have. So that is called the requirement. And there can be like thousands of requirements. Okay, so in a specific project, and there is not only like one or two requirement, there can be like hundreds of different requirements. And again, the requirements can be very minute as well. Like one requirement can be like the color of the button should be red, the font should be Arial, or the font size should be 16 pixels. So these are the minute requirement, and again, these are called requirements because it talks about the specific feature of the application, and that's what the requirement is. And again, the requirement can be divided into functional requirement as well as business requirements. Okay, so the functional requirement talks about the functionality of the application. Okay, and based on the definition, it's the specific functionalities and operations a system or product should perform. And again, when we talk about the Gmail application, right? So one functionality can be when the user enters all the details and clicks on send button, email should be sent to the receiver. Okay. Second functionality is when the user sends an email, that email should be displayed in the sent item. That can be another functionality. Third functionality can be if the user selects a email and click on delete, the email should be deleted from the inbox. So that these are called the functional requirement, which are basically related to the functionality of the application. All right. So that about the functionality, and I can see Ambrish has a question. May I know about the code for QA group in Facebook? Yeah, I share Ambrish. I'll share it with you, okay, after the call on the WhatsApp group. If you are not part of the WhatsApp group, do let me know. I'll add you. Okay. All right. So moving ahead, then after functional requirement, we have business requirements. Okay, and business requirement is something which talks about the high level objective that a project or product should achieve. So again, take into consideration about the Gmail application. So for the Gmail, right, the business requirement can be like one thing would be it should be able to send users should be able to interact with each other through emails, so which is a very high level objective. Okay, that can be one business requirement. Second business requirement can be like users are able like users should be, or Gmail app, right? It should be able to send user information to the Gmail server so that they get all the information about the user and their usage. Okay. So again, these are very high level requirement which are not specific to any functionality of the application. Okay, it is more specific to the business, something which will positively impact the overall business, not specific to the application, but from the business standpoint. Okay, on a very high level. So that is the business requirement. But again, when we do the testing, right, for the basic testing that we do as part of the manual testing, we should be majorly concerned about the functional requirement because that's something that we would be testing. Okay, business requirement, we should know what is the main objective of this specific project, why this application is built, how this application will help the business. Okay, how this application in this example, how Gmail application will help Google achieve its goal. So all those things we should know, but majorly like 90% of the thing that we'll be doing right as part of the manual testing will be related to the functional requirement. Okay. All right. So moving ahead, I have one question from Kiran. Sir, is it recorded? Yes, it is being recorded. All right. So moving ahead, let's talk about the defects. Okay. So defect is a deviation or flaw in a software application or system that causes it to behave in an unintended or incorrect way. Okay. So what happens, right? Let's take an example of again take an example of Gmail. So over this specific 3-day period, for the example purpose, I take make use of Gmail because that's something that many of you have already used it, and it will be very easy for you guys to relate to it. And that's the reason why I'm taking that example. Okay. So when we talk about the defect, let's take an example of the Gmail application, and you are trying to send an email. Okay. You drafted everything, and you clicked on send. You were expecting that when you click on the send button, email will be sent to the receiver. Okay. But what happens, right? Let's say you click on send, you and that specific email, you are able to see it in the sent item, but the receiver did not receive that email. Okay. So that is the deviation, right? Your expectation was when you click on send email, the email should be sent to the receiver. But what happened was when you clicked on send button, the email did not get sent. Okay. It got stuck somewhere, or it got deleted because of the some issue in the code. Uh, you don't know. I don't know what exactly happened, but there was a deviation from the expected result. Okay. And the actual is something different from the expected result. So that is called a defect. If there is a deviation from the expected result, it is called a defect in the application. I'll take another example of Gmail. So let's say you selected a specific email, clicked on delete. Okay. And your expectation was that email will be deleted. Okay. You clicked on it, clicked on the selected the email, clicked on the delete button, and the email did not get deleted from the system. So that is another defect. So that is another deviation. The expected was email should be deleted, but the actual result was email did not get deleted. Okay. So that is a defect. So any deviation or flaw in the application that causes it to behave in an unintended or incorrect way is called a defect. Okay. Now the next two terms, right? Reliability and quality. So these two terms are related to the defect. Okay. So reliability refers to the consistency and dependability of an application to perform its intended function accurately and consistently. Okay. So let's say I'm using a Gmail application and I'm trying to send email. I'm trying to send email to 10 different users. Okay. Individual emails to 10 different users. I across all those 10 times when I sent the email got delivered successfully. Okay. That means that the Gmail application is reliable. Okay. Every time I'm performing the action, it is doing exactly what I expected it to do. Okay. So in case, let's say out of 10 times, 2 times it is not getting delivered, then we can say that the application is not reliable. Same thing with quality. Okay. So quality refers to the degree to which a software application or system conforms to specific requirement, meets user expectation, and satisfies its intended purpose effectively and efficiently. Okay. So again, when we talk about the quality, right, it is more related to the defect. If let's say overall application is defect free, okay, based on our testing we did not find any defect, we can say that the application is of very high quality. And let's say we did manual testing of the application and we found that like out of 10 different modules, one module is not working correctly, we can say that quality is not that great when we talk about the application. Okay. Yeah. Moving ahead. Okay. So there is a question from Shushma. What's the difference between defects and error? So again, that depends. Okay. So as I mentioned earlier, a defect is something, if there is any kind of deviation from the expected, uh, you can like say that it is a defect. And error is something like, let's say you are doing any specific work on an application. Let's say a Gmail application. You're trying to send out an email, and Gmail server is uh, not responding. Okay, and Gmail throws you an error pop up saying that there is a issue with the Gmail server, and that specific thing, the pop-up that you see it, that is an error that happens during the runtime. Okay, but that did not happen during the testing process, because during the testing process the server was working perfectly fine and you did not find that issue. But let's say during the testing purpose, right, if you find that issue, then you can call that as a defect because you found it during the testing period and you said that this is something which was not expected. But let's say once the testing was done and in the production, uh, once the product is launched to the client, right, or to the people, or if the feature is launched, if you see that thing, you can say that that is an error that we are receiving. And then later on, uh, when the company discusses about that issue, right, then they can call it as defect. Okay, based on the discussion. But initially it will be error once it is found in the production, and then they can discuss about it and understand what exactly is the root cause. It if it is specific to the application, then they can call it as a defect. Or again, if it is specific error, something to this related to this server, then they can like try to fix it by fixing the resources and making sure that the server is up and running. And again, when we talk about the error, you can say that if it might not be a defect when it is the error pop-up, right, is as expected when it is designed to show the error pop-up. Okay, so let's take an example of Gmail again. In the to field, okay, when you when you send an email, in the to field, it asks you to enter the email ID. Okay, so based on the application development, right, the developer might sorry, the development might write the code saying that if someone enters the email ID incorrectly without any at the rate field, just display an error on the screen for the Gmail application. Okay, so in that case, let's say you are entering the email ID in the to field, and without entering the at the rate sign, you try to click on send. Gmail will throw an error, display an error pop up saying that you need to enter a valid email ID. Okay, so that is an error, and that is something which is as expected, because that is something that I was expecting. That was something which is specific to the requirement and that was provided to me. In that case, right, and that is not a defect. That is something which is an error, but again, it is a valid pop-up, valid message depending on the requirement, because that is something that I was expecting from the application. Okay, so that's the difference between error and defect. All right. So moving ahead, let's understand how exactly the QA project works in projects work in IT industry. Okay. So initially, what happens, right? When a client determines that they want to do a specific software testing on an application, the first thing that they do is identify a vendor. Okay, identify who exactly can help me getting this software tested. Okay. So once the vendor is identified, right, client goes to the vendor, talks to them, talks about the project scope, and then there are different levels of discussion regarding the pricing. The vendor provides us them with the pricing, then client approves it, client agrees to the pricing for the service and all the stuff. Once that happens, right, a vendor will accept the project. If again it has to be both ways. Okay, so client will provide with their requirement, vendor will say that this is what we need in return for this service, and if both of them are in agreement, okay, then the project is accepted. And once the project is accepted, right, so what vendor does is it assigns a QA tester to the project, and then QA starts with the testing process. And as part of this specific step, right, the QA will be responsible for understanding the requirement, then creating the test plan strategy, understanding what all things needs to be tested as part of this project, and then creating the test cases, scenarios, test data, execution, and reporting summary, everything. Okay, so once the testing is done, then QA provides a sign off. A sign off mail or sign off is something is a formal document that QA provides once the testing is done, saying that these are the different things I have tested, and this is the final outcome. If the testing is passed or fail, QA pass, QA fail, all those things will be mentioned in the sign off document. Okay, and let's say if there is a if everything works perfectly fine, QA says that the project is working perfectly fine. We did not find any more issues. We found a couple of issues which got fixed during the development cycle, and now the code is free of any issue. At that time, client accepts the project, and then the software is released to the audience in the market. So this is the overall very high level step that currently works in the uh, industry. Okay, and again, this is on a very high level. When we go to day two, right, tomorrow, I'll talk in depth on the requirement, how exactly requirement looks like, and what are things we need to look into requirement, and then as part of the testing process, right, how exactly each and every step works. I'll be talking more in detail tomorrow. Okay, so that's something that is coming up. And yeah, so this was on a introductory part on how exactly the software industry is structured and what how exactly things work and different terminologies. Now let's get started with what exactly the software testing is. Okay. Now that you understood the basics, now that you understood basic terminologies, it will be very easy for you to like understand all the future slides that we have for the software testing, because the basics are covered. Now the terminologies are covered. Now the basic concept or the concept that we have, right, for performance testing, like different types of performance testing, all the stuff, it will be easy for you to understand that. So what is software testing? So software testing is a process of evaluating a software application or system to find if it meets specific requirements. Okay, so as I mentioned earlier, taking an example of Gmail, Gmail has got a specific set of requirements, like sending an email, receiving an email, deleting an email, and then the send button size, the font size of the text in the Gmail application. So all those are the requirement. So software testing is a process wherein you go through the application manually and you compare it with the requirements and making sure that it meets the requirements specified in the requirement document. So that is the software testing. So it's very simple to understand. It's just matching what you have in your hand, the application, compare it with the requirements, and evaluate it. If you find any issue, if there is any kind of deviation, you raise a defect. If there is no deviation, you say that that this software is meeting that specific requirement. Okay. So and about the goal of software testing, so every task that we do, right, everything has a specific goal. Without goal, and there is no point doing any specific task. Okay, be it a software testing or development, anything. Okay, so for software testing also there is a goal. There are specific goals. Okay, for software testing. So the number one goal of software testing is finding defects. As I mentioned earlier, we need to compare the actual versus expected. Okay, and if there is a difference, if it is not as expected, then you call it as a defect. Okay, so the number one goal is to find defect, then verifying functionality. Again, both of them are related, finding defect and verifying functionality. So when we verify functionality against the functionality document, functional document, requirement documents, and if we find any deviation, we call it as a defect. So the second goal is to make sure that we verify functionality, each and everything that is mentioned in the requirement document. We make sure we test, we verify those functionality against the software that we have. Okay. The third goal is ensuring reliability and improving quality, making sure that the application is reliable to use for the general audience. So that is another goal that we need to consider while doing the software testing task. And improving quality, making sure that we find as many defects as possible, making sure that the application is user friendly, it is usable by the uh, audience, okay, by the target audience. So all those things, right, we need to make sure that happens, and by making sure that in case there is any kind of defect, we raise it to the development team, get it fixed, and retest the defect once the fix is available. Okay, and that makes sure that the quality is improved as part of the application. So these are the four goals: finding defects, verifying functionality, ensuring reliability, and improving quality. Okay, now there are different principles of software testing. Okay, so make a note of these points because this is very important, and this is something which are like always asked in a software testing interview. Whenever you go for an interview as a fresher, or let's say if you are going, if you have like 1 or 2 years of experience and you try to switch a job, right? So in that case, this one is very important because these are the things that are like related to software testing, and this is something which is always being asked for the freshers. Okay, so there are 7 principles of the software testing. Principle one says that testing shows the presence of defect. Okay, so when we do this software testing, it does not show us absence of defect, but it will definitely show us with the presence of defect. So when we compare the application with the requirement, if there is any deviation, it will show us that. Okay, but you cannot say that a software is 100% free of defect, because that is never possible. You cannot say that it is 100% defect free. Okay, there has to be a defect somewhere, but which is unknown to the end user. Okay, and that is something that's it's not a rule, but that's how exactly it works. So not all software is 100% defect free. So you need to remember this. Even during the interview, if someone asks you, right, can you make a software, can you test a software so that it is 100% defect free, you can't say yes. You have to say no, because that's not possible, because you can't test each and everything. Inside the code there might be a one line of code that is causing a defect but not covered as part of the testing scenario. That can happen. Okay, you can't say that you can make 100% defect free application, 100% defect free. You can say that you can make sure that the application is 99% defect free. You can't guarantee 100%. Okay, so the principle number one says that testing shows the presence of defects. Number two says that exhaustive testing is not possible. As I mentioned just now, we can't test each and everything. You can test like all the functionalities. Okay, you can spend 1 month testing the application, but it's not possible to like keep on testing to find the defect. And there will be a point where you will be saying, and this is enough, and enough of testing. I can't test more, because everything that was covered in the requirement document, everything that came to my mind as part of the scenario, I have covered everything, and now I can't test it. Okay, so there is a limit on the testing as well. You can't keep on testing indefinitely. So that's the principle number two. Exhaustive testing is not possible. Third principle says that defect clustering, sorry, early testing. It is very important to make sure that we test as early as possible in the development cycle. So what happens, right? Let's say the development happens, and you start with the testing process at the very late stage, just before the production deployment. Okay, let's say 3 days before the production release of that product to the market. Okay, what happens, let's say if you find a defect, then it will be very costly to get it fixed, because the thing is, if the defect gets identified at the later stage of the development project, let's say just 3 days before the release date, then the developer will have to uh, look into issue, get it fixed, and that fix, right, it might have negative impact on the other modules as well. And again, that needs to be tested thoroughly. Okay, so this will be a very time-consuming process in case the testing is done later stage of the development cycle. If it is done something at the earlier stages, like during the development, if you test it and find the defect, it will be very easy for the developer to fix it. It will be very easy for the QAs to test the overall model, because there is a very less chance of having a negative impact on the other models. And in case we find any defect right in the other model, then we still have enough time to get it fixed and get it tested. Okay, that's the reason why early testing is very important. And then the fourth principle is defect clustering, which follows uh, the Pareto principle, okay, which says that 80% of the 80% of the defects are found in 20% of the module. So let's say there are 10 modules, okay. Out of those 10 modules, 2 modules will have majority of the defects. Okay, so that is the principle. Okay, and that is true in majority of the case. And let's say there are 10 modules, then out of those 10 modules, there will be two modules which will have majority of the defects. Okay, so that is the principle. And then the fifth one is pesticide paradox. So what happens, like when we create a test case, okay, set of test cases, pesticide paradox says that those set of test cases, if you execute for the first time, it will find a defect. If you execute for the second time, you may find another defect. If you execute for the third time, you may find another defect. Okay. But if you keep on executing, you see, keep on repeating same test of set cases every now and then there will be a point where you will not find any of the defect. Okay. That's the reason why it is very important to keep on reviewing the test cases, keep on making sure that the workflows are updated, keep on making sure that the test data is updated in order to make sure that it finds a new defects. Okay. Principle number 6 is that testing is context dependent. Okay. Again, when I say context dependent, right, it means that different application needs to be tested in a different way. Let's take an example of gaming. Okay, games needs to be tested in a different way. Game needs to be tested by playing the game, and then there has to be some kind of automation that keeps track of the different metrics of the game, like the scores and all those stuff. Okay. If you talk about the banking application, it has to be tested in a different way. When we test the banking application, we need to take into consideration the security of the application as the topmost priority. When we talk about the different application, right, let's take into consideration of the healthcare application. Again, healthcare application has to be treated in a different way compared to banking application. Healthcare application has got the patient health data that needs to be taken care into as a separate, like in a separate context compared to the banking application. So testing is context dependent, depending on the type of application. And the approach for the testing will be different. Okay. And then principle number 7 says that absence of errors policy. That means, as I mentioned at in the first point, you can't say the application is 100% free of errors or defects. Okay, so that's what principle 7 says, that absence of errors policy, application can't be 100% defect free. Okay, you can't say that this application is free of defect, this application of does not have any kind of defect. You can't say that. So that's the principle number 7. So these are the 7 principles of the software testing, and make sure you understand each one of them. And again, what I would suggest, right, I'll be sharing the recording after this session. So you go through this recording again so that you get a clear and fair understanding of these topics again. Okay. And if you have any question, feel free to ask me in the Q&A. Okay. I'm keeping a watch on the Q&A as well. All right, just a second. Okay, so I have a poll for you guys. Okay, just let me know. Just reply to the poll so that I can gauge your understanding level. If you have again, if you have any question, then do post on the Q&A tab. But feel free to uh, answer the poll so that I understand how much you are able to understand. Right. So I'll wait for one more for the publishing the result for the poll. So I have published the poll, and it says majority of you guys have answered defect, and there was one student who answered it as requirement. So I don't want to call out the name, but again, I just want to repeat, if there is any kind of deviation in the software, if it is not matching as expected, then it is called a defect. Okay, requirement is something which is like the feature of the application. Okay, so that's something which is called requirement. Right. Okay, so moving ahead, let's talk about the software testing life cycle. Okay, So when we do the software testing, right, there are series of steps that we need to follow as part of the software testing. So the first thing is requirement analysis. So when a project comes, right, the first step is to analyze the requirement, understanding the requirement, and go through each and every step, like go through each and every requirement, what exactly the software is capable of doing, what exactly it is expected to do. All those things will do as part of the requirement analysis. Then the second step is test planning, wherein we'll create a plan for the execution. Okay, what all types of testing that we'll be performing and all those stuff. I'll be talking about all this stuff in the upcoming slide. And then comes the test case development, wherein we'll create the test scenarios and test cases. And after that, we'll do the test environment setup, wherein we'll and set up the environment for the testing, making sure that the application is available, the test environment is available, and then we do the execution. And once the execution is done, we send the closure a letter to the client saying that the execution is done and this is what the results are. Okay, so this is the overall cycle of the software testing, and let's get in depth into all these points. Okay, so the first thing is requirement analysis. Okay, so as I mentioned earlier, a requirement analysis is the initial phase wherein you go through the requirement, you analyze the functional and non-functional requirements, understand the user's expectation, what is expected from this application, and if there are any specific constraints or any specific thing relevant and that needs to be understood, it will be all mentioned in the document, and then we understand all those things as part of the requirement analysis. And then another thing that we need to cover, right, as part of requirement analysis is you need to list down the questions in case a specific requirement is not clear. And when you go through the requirements, then it becomes like your job to make sure you make a note of it and then ask questions to the person who provided you with the requirement. If something is not clear, you need to make sure you understand the requirement, because unless until you understand the requirement, it will be very difficult for you to write test scenarios and test case and do the execution. So this is very important phase. Understand the requirement. If you have any question, make sure you get your questions answered. Okay, then comes the test planning phase. Okay, so test planning involves planning of the testing activity, wherein like there are a few things that we need to cover as part of the test planning. We define the scope, we create a test strategy, we do the resource planning. When I talk about the resource planning, we list down who all team members, right, from your team, who all will be working on the execution, who all will be doing the test scenario, who will be creating the test cases and all the stuff, who will be doing execution. Everything will be taken care as part of the resource planning. Then we'll identify the testing schedule and timelines. Then we document the risk. We identify the risk. We create a risk identification, mitigation, and contingency plan as well. Okay. Then what all test deliverables will be part of this project? We'll be documenting that. Like, for example, as part of this project, this is something like we'll be providing you with. One is a test plan, test strategy, test case, test scenario, test execution report, defect report, and summary report. So this is the test deliverables. Okay. And then communication reporting, with whom are we going to communicate, and what and to whom we'll be reporting, and what exactly the structure would be for the reporting. Will it be sent through email, or we'll be creating a specific document and upload it to a specific location? How exactly the reporting will be done, and the review and approval, like who will be approving the final test result and all those things, everything, right? The things related to planning, everything will be taken care as part of this specific phase. Okay, and as part of test planning, right, there will be two major document. One is test strategy document, and then test plan document that will be created as part of the test planning. All right, so moving ahead, test case development. So once the test planning is done, once the requirement analysis is done, test planning is done, the next step is test case development. So as part of test case development, what we'll be doing is we'll be creating test scenarios and test cases. Okay. So a test scenario is a very high level test case, and then test case is part of test scenario. Okay. So one test scenario can have multiple test cases. We'll talk about it tomorrow. okay, when we do the hands-on and test scenario creation and test case creation. Okay, so as part of this phase, we'll be creating test scenarios and test cases. Then comes the test environment setup. As I mentioned earlier, before we do any kind of testing, we need to make sure that the test environment is available. Okay, the application is available, the environment is set up, the test data is set up. So all these things are taken care as part of this step. Okay, so once this step is done, once the setup is done, we'll do with the test execution. Okay, so this is another important phase of the software testing, wherein we'll do the actual testing of the application, wherein we'll compare with the expected versus actual. Okay, and in case we find any issue, then we raise a defect. So that's something that is part of the test execution phase. And once the test execution is done, we have the test closure phase, wherein we do the final, which is a final phase of the testing process, wherein we create a summary report, send it out to the client saying that the test passed or failed, whatever, depending on the testing process, right? So that's something that we'll do as part of the test closure. All right, so let's move on. Okay, so if you guys have any question, feel free to ask me. Just a second. I have a couple of questions in here. So Samir saying all agile practically. Yes, Samir. Right now, like industry has moved to the agile methodology. But the reason why I'm covering this waterfall model, right? Because this is something which is very basic that everyone will be able to relate to. Okay, agile is a separate topic in itself, which will take a separate session to cover. But waterfall model, right? That is something which industry has been using since like the start of the software journey, and it will be very easy for folks to relate to it, and that is the reason why I covered this waterfall model here, just to understand the basic concept, because we don't want to get into agile and make things complex at this moment. Okay, so that is the reason why this specific model is covered. Yes, Swapnil, you will get the recording. I understand you are facing network issues. Which performance tools you suggest to learn now? I would recommend learning JMeter, a JMeter performance testing tool, because that is something which is like open source and free to use. And majority of the companies, right, considering the budget and all, they use JMeter tool as a performance testing tool. How to deal with this scenario when app is about to go live on the same day you found a major bug? Okay, so this is something, right? I can help you answer on the last day or maybe after this session, right? If we have time left, then we can go through this specific question. Okay, and there is one more question from Sushma. What's the difference between quality assurance and quality analyst? I'll talk about it once we are done with these slides. Okay, I'll make sure I cover it. It's okay. Okay, right. Okay, so let's talk about levels of software testing. Okay, so there are like four levels of software testing. One is unit testing, integration testing, system testing, and acceptance testing. Okay, so unit testing, let's talk about it in detail. Okay, with this help of example. So on the left hand side, right, we have a software product. A software is made is like a combination of different modules. When we talk about the Gmail application, right, one module can be sent item folder. Second module can be like inbox folder. Module 3 can be like outbox folder. Okay, and then within the module consists of different functions. So one module can have one or multiple functions associated with it. Okay, so this is the basic structure of the software code, wherein software consists of modules, module consists of functions, and function consists of lines of code. Okay, so when we talk about the unit testing, right, so what happens, unit testing is basically done by a developer. Okay, and it is done at the code level or at the function level. So these function that you see here, right, function 1, function 2, function 3, So what happens as part of unit testing, developer tests these functions individually. If a function has got specific input field, okay, let's say function is accepting a specific parameter, what developer will do is developer will pass that parameter to the function and make sure that that function is returning the expected value or not, okay, or if that function is performing that specific operation or not. So that is something which is called unit testing, which is done by the code developer at the function level or at the code level. Okay, and then we have integration testing. Okay, so integration testing is related to integration of different modules. So let's say module 1 and module 2. I am test if I want to test the integration of module 1 or and module 2, I want to test how exactly these modules are interacting with each other. Okay, then I'll do the integration testing on module 1 and module 2. Similarly, for module 2, module 3, if I want to see test the interaction of these two modules, I can do the integration testing of module 2 and module 3. And when we talk about the Gmail application, the send, let's take an example of inbox, sent item and outbox. Okay, so when we send an item, when we send an email, okay, so initially it appears in the outbox. Once the email is sent from the outbox, it appears in the sent item. Okay, so that's the ideal flow or the usual flow of the Gmail application. So when I talk about the integration testing, that I'll test the integration of outbox and sent item if those two modules are integrated correctly or not. Okay, so that's something which comes under part of the integration testing. And again, as part of the integration testing, if there are like 3 or 4 or 5 modules, right, I can test the integration of, let's say, 3 modules or 4 modules. I can do whatever integration I want just to make sure that those modules, right, are working correctly when integrated with each other. Okay, and after integration testing, we have another level which is called system level testing. Okay, so when I say system level testing, it is the testing of the overall system, like all the modules, everything that is integrated together, and we are testing it. Okay, so this software product has got 3 modules. What I'll be doing is I'll be making sure that all the modules are integrated together, and as a system, right, as a software as a whole, I'll be testing it, making sure that the end-to-end module integration are working correctly without any error. So that's something which is tested as part of the integration testing level. And then comes the acceptance testing. So acceptance testing is something which is done by the business owners, okay, or the product owners, I would say. So this is to test the overall business requirement of the application. So let's take an example of Gmail, right? So Gmail overall requirement of the Gmail is user should be capable of sending email, receiving email. So that is the very high level business requirement. So as part of the acceptance testing, I'll make sure that these basic functionalities are working. I won't get in depth on the functionality testing as part of this acceptance testing, but on a very high level, whatever is the business requirement, I'll make sure that it is tested as part of this requirement, as part of this testing level. Okay, so that's about the 4 levels of software testing. And then we'll talk about the V model as well. Okay, so this is another important thing which has to be considered. Okay, and you need to understand this because this is another uh, topic which is most widely asked or most commonly asked in an interview. Okay, so what is V model? So V model is also known as verification and validation model. Okay, a VNV model. It's also called VNV model. It's also called verification and validation model. It's also a V model. So V model shows the relationship, okay, between the development phase and the testing phase. Okay, on the left hand side, if you see here, right, that's the development phase, and on the right hand side, we have a testing phase. So V model shows the relationship between the development and testing phase. And if you see on the development phase, we have a requirement gathering, system analysis, software design, module design, and then we have a coding. And if you remember, I spoke about the unit testing. So unit testing is done at the module level design, okay, wherein we test the functions of the module, okay, and then the integration testing is associated with the software design, so integration of the different modules, and then understanding the system requirement, right, the architecture of the system. At the system analysis part, we have a system testing, and then going through the requirement, understanding the business requirement and all this stuff on a very high level, we do the acceptance testing. So when we I show this relation, right? Requirement gathering and acceptance testing. Here we have the acceptance test requirement or a, a specific test case, acceptance test case. Then we have system level test case, integration test cases at the integration testing level, and then unit test cases at the module level. So the test case part, I'll be talking more about it tomorrow. Okay. So this is what the V model looks like. The basic definition of V model is it shows the relationship between development phase and the testing phase. Okay. I see one hand raised by Samir and then Sushma. Just a second. Okay. All right. And then let's talk about verification and validation. So what exactly is verification and validation in the V model? Okay. So verification answers the simple question: Are we building the product right? Okay. So it talks more about the process that is followed as part of the development. Okay. So the process that is followed right as part of the development, making sure that the code is reviewed and a requirement is understood in case like as part of the requirement document in case the developer finds any issue or any concern or any question, all those things, right? The process to make sure that the requirement understanding, creating the architecture, designing the software, creating a specific function, all the coding standard, everything related to the process, everything is part of the verification phase. And then validation answers this question: Are we building the right product? Which means it is us like are we building the right product means are we making sure that the application that is being developed is right or wrong? Is it according to the requirement or not? So that's something which we are doing as part of the validation. And QA, right, as part of the QA role, this is something that we do. We are doing validation. Okay, we are making sure that the product is built right. Okay, so we are building the right product, making sure that the product that is being developed is meeting the requirement. Okay, so that's the difference between validation and verification. And again, this is something which is commonly asked in the interview. So make sure if you have any question, then let me know. Okay, so verification is are we building the product right, which majorly concentrates on the process, and validation is are we building the right product, which majorly uh, talks about matching the application with the requirement. Okay, which is basically testing. So testing part is the validation part. All right, so let's move ahead with the different types of testing. Okay, so let's talk about the white box testing. So white box testing is a type of testing, application testing, that examines the internal structure and design of software application. So this type of testing, right, we talk about like we have a look at the code and do the testing. So it's not specific to functionality, but specific to the code. So let's take an example of this specific program code. We have a function called calculate, which accepts int one and sorry, number one and number two. It performs the addition, and depending on the number, right, outcome of the result, it displays high or low. Okay, so we know that code as a white box tester. My job is to understand the code, and my job is to read the code and see how exactly the code is working, and based on that I'll pass the input into the uh, as a parameter different input and see how exactly the function is responding. So I might enter like 10 and 5 here and see if it is displaying high or low. Maybe like -1, -2 as number one and number two, and see how exactly the it output is displaying. Maybe I'll pass a string here for number one and some decimal value for number two and see if it is throwing an error or not. All those stuff, right? I'll test as part of the white box testing. Okay, so white box testing is specific to the code. Then we have black box testing, and that is something which is also called as the functional testing, wherein we do not have any information of the code, or we as a tester, right, we do not intend to have a look at the code. Okay, so what we do as part of the black box testing is we get the application, we perform the action based on the requirement, we see that if it is matching the actual or not, sorry, matching the expected or not. Okay, and we compare it. So again, taking an example of calculator, I am not concerned about the code here. I'll simply pass the input I'll see what exactly the output is and I'll match it with the expected outcome. That's the only thing I'll do as part of the black box. I am not going to be uh, worried about the code, how exactly the code is written. That is none of my concern as a black box tester. Okay, I'll simply test the functionality. I'll pass on the input. If it is giving me expected output, well and good. If no, I'll raise a defect. And majority of the time, we do the black box testing. Okay, I would say like 70 to 80% of the time, we do black box testing. And then we have other different types of software testing. One is unit testing, which we already spoke about. Then we have integration testing, wherein we talk about the integration, wherein we test the integration of different modules, okay, within the application. Then we have system testing, wherein we test the overall application as a whole. Okay, so these three types of testing we already spoke about in the previous slide when we discussed about the different levels of testing. Then we have functional testing. So functional testing is a type of software testing that verifies the functionality of an application or software system. Okay. Again, this is something which we usually do as part of the testing. The black box testing is functional testing. Okay. And then, yeah, so taking an example of Gmail, when we test the application, right, for sending an email, whether it got sent or not. So that is another part of that is another uh, type of function, that is another example of functional testing. Okay, so functional testing is basically testing the functionality of the application, making sure that it is working as expected, as mentioned in the requirement document. Then we have non-functional testing, which tests the non-functional aspects of the application. Okay, so examples of non-functional testing is performance testing. Then we have security testing. Uh, then there is another usability testing. So these are the different types of non-functional testing, which test the non-functional aspect of the application. Okay, I'll talk about the performance testing in the upcoming slides. Okay, and then we have another type of software testing, which is a smoke testing. Smoke testing is a very high level type of testing. Okay, so when a developer, right, it provides us with the build or provides us with the application to test. So the initial test that we perform, okay, just to make sure that whether the application can be used or not, or it is testable or not, that is something which is called a smoke testing. So smoke testing is a very high level testing. So let's take an example of Gmail. Okay, so if someone gives you an application, let's say Gmail application, to test it. Okay, so the first thing that you will do is whether I am able to launch the application or not. That's it. If I'm able to launch it, yes, I can test it. I can go ahead with the testing. Okay. If the application is not launching, then testing is not possible. So that initial high level testing, right, that we do, just to make sure, just to check whether the application is testable or not, that is called the smoke testing. Okay. Then we have sanity testing. So let's say we have a test case, 100 test cases. Okay. So out of those 100 test cases, as part of sanity check or as part of sanity test, what I'll do, right? I'll pick 10 critical modules, 10 critical test cases, 10 very important test cases. Okay. And I'll include as part of the sanity testing suite. Okay. So as part of sanity testing, what we do is we test the application. Okay. Whenever we receive a build, these uh, small test cases, okay, we execute just to make sure that the basic functionality of the application is working fine. Okay, so that is the sanity check. And then we have end-to-end testing. Okay, so end-to-end testing again is close to the is related to the system testing, wherein we test the overall system as a whole. But when we do the end-to-end testing, right, we test the overall application plus the integration of the application with the third party. Okay, so again with the Gmail, right, there might be integration like uh, if I click on if I'm logged into the Gmail application, if I click on Google Drive, it should successfully log into the Drive application. Okay, so that is one integration of the software with the third party or the different application. So there may be many other integration as well with the application. So when we do the end-to-end testing, we make sure that the overall application, along with its integration to the third-party application, is tested. Okay, and then we have regression testing. Again, regression testing is something that we'll cover tomorrow. I'll talk about it tomorrow in detail. Okay, so it is type of testing that verifies whether recent code changes haven't adversely affected existing functionalities. Okay, so let's take an example of Gmail again. Okay, so Gmail has got a feature called as send email. Okay, so let's say you find a defect uh, in the send email functionality. Email is not getting sent. Okay, so that email got reported, that defect got reported. Development team fixed that defect and send it back to you for further testing again. So what you will do, right, as part of regression testing, you will identify test cases, okay, related to that specific functionality plus any other functionality that is related to that send email functionality, which you think might affect negatively. So you identify those other features as well and create a suite of test cases that you will test as part of regression test. So regression testing is testing the functionality for which you raised a defect and all the surrounding functionality that you think might get impacted because of this feature. Okay, so that's the regression testing. And then we have performance testing, as I mentioned earlier. It is a way to evaluate how system performs under a specific workload. And then security testing is testing the vulnerability of the application to cyber attacks or any specific security issues. Like if someone is trying to hack the application, right? As a security tester, I'll try to hack the application and make sure that I'm successful in hacking the application, and I'll also need to make sure that the application, right, is making sure of taking care of such hacking attempts. Okay, so that comes under part of security testing. And then usability testing is basically related to the quality of the application. It is used to assess how easy user interface are to use. Okay, so that's something to do with the usability, making sure that the application that you test is usable to the end client. So if you are the client, right, if you are the end client of the or the end user of the Gmail application, it is very important to make sure that you as a user, uh, it's very easy for you to access the Gmail application. Okay, so that's the usability testing. And then let's talk about the performance testing. Okay, we still have like a couple of minutes left, so I'll quickly cover the performance testing. So as I mentioned earlier, performance testing is a way to assess the performance of the application. So let's say there are like 100 users, billion users are accessing the Gmail application. I want to make sure that when I click on the inbox, for me as a user, I get the my inbox is loaded as quickly as possible. Okay, so that is something that performance testing does, and just to make sure that if there are like 100 users accessing the application, the more specific module returns the data or it works as quickly as possible. Okay, so there are different types of performance testing available uh, that we can do on an application. Okay, so the first thing is load testing. Okay, so what exactly load testing does? Load testing measures the system performance as the workload increases. Okay, and again the load test, the workload that we use, right, the load testing, it falls within the parameter of normal working conditions. So let's say I have an application called ABC, okay, or XYZ. Let's take an example, application XYZ. Okay, so my expectation as a product owner or as an application owner, I expect that this application, uh, if there are like 100 users using the application at the same time, it should not throw any error. It should load within like that specific page should load within 3 seconds. Okay, that is my expectation. Okay, so as part of load test, right, what I'll do, I'll test this application. I'll put 100 users, 100 concurrent users on that specific application, and I'll see how exactly the application is responding, how much time the application is taking to respond. Okay, when I put 100 users uh, on that application. So that is the job of load test. Okay. So again, if you have a look at this graph, this is how it looks like. And if you see here right now, as part of this test, okay, we have 500 concurrent users. Okay. If you see, it starts, the load test starts here. And at what one point, there are 500 users who are accessing the application. Once the access is done, once the application access is done, those 500 users will shut down and it will go back to zero. Okay. And once this execution is done, right, the metrics that we get from the performance testing tool, it will return different metrics like response time, average, minimum response time, and then maximum response time, and all those stuff. I'll capture the response time that I need to monitor, and I'll report it to the application owner. Okay, so that's the load test. Then we have stress test. Okay, again it is similar to load test, but stress test is like putting a stress onto the application server, or putting a stress onto the application which is higher than the normal. So let's say the application XYZ, right? The expectation is that it should handle 100 concurrent users. Okay, that is the expectation. But when I do the stress testing, right, I'll make sure that instead of 100, I put 200 users load and see how exactly the application is responding. Like if there is any kind of like sudden increase in the number of users, I want to make sure that the application is handling correctly without any kind of deterioration in the performance of the application. Okay, so that is the stress test. And again, if you see here, right now, if you see this specific graph, there are 1000 users accessing the application. So initially in the previous chart, we had 500, but as part of the stress testing, we have 1000 users accessing the application. It started from zero, it went up to 1000, it started using the application. And once the application usage is done, the number of users ramped down from 1000 to zero again. Okay, so that is the stress testing. Then we have endurance testing. Again, that is part of the performance testing. So endurance testing is more like a load testing, okay, wherein we run the test with the normal workload. So in this case, if you see with 500 users, but instead of running, let's say for 1 hour or 2 hour, right, we make sure that the test is run for the entire daytime, maybe 8 hour period, 6 to 7 to 8 hour period. So that's what the endurance test is. So the normal workload over an extended period of time. So that's the execution timeline that we follow as part of endurance test. Again, the goal here, right, for the test is to make sure the response time is within the expected parameters. Okay, so that is one goal. And then second goal is to check for the memory leaks in case there is any kind of memory issue, right, in the application. Then we can test that as part of the endurance testing. Then we have spike test. Spike test is something which is combination of load and stress test. Okay. So as part of spike test, what we do is we do the normal workload, normal load test, but in the middle, right, we add a spike in the user. So let's take an example of Netflix. Okay. So Netflix, let's say it has got like 1000 users per minute accessing 1000 user, and or per hour, let's say it has got 1 million users, okay, accessing the application. And Netflix announced release of a specific uh, release of a very popular movie, and they are about to stream it online on a specific date. Okay, so what is expected, right? So normal workload is 1000 like 1 million user per hour. Okay, that is the normal workload. But on the day of release, right, on the day of launch, we Netflix is expecting, let's say, 5 million users. Okay, so that is a spike compared to normal workflow. There is a spike in the user that is anticipated. Okay, so that's something that we can test as part of the performance testing. So this is how it works, right? So it starts from zero, it increases up to like the normal workload. In this case, it is like 450. It is increasing, and then there is a sudden spike. It went up to 600. Now it came back to 400, then it's normal, and then there is a sudden spike here. It came to 550. It came back to normal. So there is a spike in the usage of the application, and this type of testing test and is used to understand how exactly the application is performing when there is a sudden spike in the usage compared to the normal workload. Okay, so that's the importance of spike testing, and it is very important to do that as well, because when there is a specific feature, right, being released in the market, so it's very important to test it, because we might expect sudden increase in the usage of that functionality, and we need to make sure that we test that specific thing in the application in order to handle any scenario such kind of scenario. Okay, we don't want the application to crash, and that is the reason why it is very important to do this pipe testing as well, in addition to load testing. And then we have scalability testing. So these are like the very less used or not frequently done in the industry. But again, this is very important to understand, because there are like out of 10 projects, there might be like one or two projects that does scalability testing and volume testing. Okay, so what exactly is scalability testing? So it is used to determine if software is effectively handling increasing workload or change in the server resource. So what happens, right? When we do the load testing, uh, we can, the backend, we increase the number of resources or reduce the number of resources. When I talk about the resources, I'm talking about the number of servers and all those stuff. Okay, number of servers, CPUs, and then memory and all those stuff. Okay, so this is how this scalability testing works. Okay, so load test is executed, normal load test is done, and during the process, right, during the execution process, from the backend, someone will go and remove one server from the application, or someone will like a developer will come and add a specific resource, or increase the CPU, or increase the memory, or reduce the memory, or reduce the CPU. Okay, and the developer or someone from the team will make that change at the server level. And the goal of this testing, right, is to make sure that the application handles these changes during runtime. It should not return an error saying that there is a change in the as in the resources, so it should not return any specific error in the application. So that is something that we test as part of the scalability testing, just to make sure that if there is any change in the workload or change in the resources, the application is successfully able to handle that change. So that is part of the scalability testing. And then as part of the volume testing, we make sure that we understand how effectively software performs with large projected amount of data. So when we do the volume testing, we do the normal load test. We make sure that the application uh, has like large amount of data in the backend. So whenever the load test execute, and there might be a very high amount of usage at the database level because of very high amount of data. So that is something that we test as part of the volume testing. So we increase the volume of data in the application, and we do the testing of the application. We do the performance testing of the application to see how exactly the application is responding when there is a very high amount of data in the database associated with that application. Okay, so that's something that we do as part of the volume testing. Yeah. So this is what we have covered so far. Like we understood what exactly the terminologies are for the software testing, how exactly the IT projects work, and what are the different concepts of the test software testing. We spoke about like different levels of software testing: unit testing, integration testing, system testing, and then acceptance testing. Then we spoke about the V model. That is something again very important when we talk about the interviews. So that is something which is commonly asked. Then we spoke about different types of software testing, and then we covered the performance testing basics to understand what exactly performance testings are and different types of performance testing. Okay. So tomorrow, what we'll be doing, right? Tomorrow will be very interesting day, because we'll be doing hands-on the software testing. Now that you understood the basics of manual testing, we'll be doing hands-on tomorrow, wherein we'll understand the requirement documents. We'll see how exactly document looks like. We'll create test scenario, test cases, and we'll do the execution. Okay, I'll share the templates for the test cases. I'll share the templates for the test scenario and execution template as well, along with the template for defect and execution summary. Okay, so these are the templates, right? You can plug and play. You can use this template in your project. Okay, you can use these templates for the projects that you are working on, or let's say you are creating a dummy project, right? Or as part of the learning activity, you are doing some testing of the existing application as part of the learning. You can just plug and play. You can use these templates and get started right away. Okay, without wasting time on creating the templates. So that's something which I'll be sharing, and then we'll do some hands-on tomorrow on the application, we'll get in depth on how to create these artifacts, which are part of the software testing. Okay, so that's something that we are going to cover tomorrow. Yeah, so that is it for today. So I'll go through the Q&A section. Okay, and before that, I have some polls for you. Okay, so by the time I go through the Q&A, just feel free to answer the question and that I have added. This will help me understand like how exactly was the topic clear to you or not. Okay. All right. So there is a question from Ritika. So what is test strategy and test deliverables and mitigation? Okay. So test strategy, as I mentioned, is a strategy on how to do the how to do the software testing. So it is a part of plan. Okay. So when we say test strategy, right, uh, we are creating a strategy, we are creating a plan on how the end-to-end testing should be. We'll talk about the resources, what are the timelines, and then what are the risks, and who all will be part of the execution. So what all types of testing that we'll be doing as part of this specific project. So all those things, right, will be included as part of test strategy. Okay, and deliverables are something which I'll be covering tomorrow. The test cases, then requirement document, scenario, test case execution, a report, and then summary report, defect report, and all those stuff, right, comes as part of the test deliverables. And mitigation is something which is related to risk. Okay, so let's say a project. Let's take an example of Gmail application. One risk of the Gmail application can be a server can be down anytime. Okay, because of some issue, XYZ issue. So that is a one risk. Okay, so we have identified that risk. Okay, we need to mitigate it. Okay, so mitigation is a plan and that we come up with for the solving that specific risk. Okay, for that server, right? As part of the mitigation process, we can say that we'll have another server as a backup in case one server goes down. That second server will automatically be triggered and all the requests will go to that specific server. So we are mitigating the risk in that case. Okay, so mitigation is basically a plan that we need to follow or we need to create as part of the uh, for the risk. Okay, all right. So there is another question. What is the difference between quality assurance and quality analyst? So quality assurance is a process that we follow. Okay. So quality assurance is a process that we follow to make sure that the application is of the high quality. So quality assurance is basically a testing process, or we can call it as a testing. So that is quality assurance. And quality as analyst is someone who does the quality assurance, who does the testing. So that person, that individual is called the quality analyst. Hope is asking, shall we get the recording of those classes? Yes, you will get it. Can you explain more about V model, like how exactly it is executed? So V model is not execution. Okay, V model is a process. Sorry, it's a framework. It just shows the relationship between the development phase and the testing phase. So that shows the relationship. It is not a execution. It is not something that can be executed. It is a process, or it is a framework. You can call it as a framework that shows the relationship between development and testing phase of the project. Okay. And yeah, that was from Manju. So Manju, if you have any further question, feel free to ask me on the Q&A. Okay. What is the difference between sanity and smoke test? Okay, so as I mentioned earlier, smoke test is a very high level test. Okay, so and sanity is a little bit in depth. So what we can say, smoke test is on a very high level. Let's take an example of Gmail application. Okay, so when a developer provides me with the Gmail application, as part of smoke test, I'll just make sure that the application is testable. Okay, and I'll just make sure application is launching so that it can be tested. But as part of the sanity check, I'll check different aspect of the application to make sure that the basic functionality, right, basic important functionalities are working fine in the application. And one major difference is smoke test is used to see if the application is testable or not. That's the only uh, importance of smoke test. But sanity check is the detailed testing of the specific of the application to uncover a defect. Okay, so once the smoke test is done, we can go ahead with sanity testing. Okay, sanity testing cannot be done without smoke testing. Smoke testing has to be done before proceeding ahead with the sanity testing. So that's the major difference. Okay, and then just a second. Yeah, so I answered that question by Shushma. What's the difference between quality assurance and quality analyst? Okay, so there is one question by Ritika. How to deal with this scenario when app is about to go live on the same day you found a major bug? Okay, so that totally depends on the scenario. Okay, so let's say uh, the application is about to launch and you find a bug, okay, just before the launch of the application. So in IT industry, right, what happens when such situation, when a project comes into this situation, right, they meet and have a discussion. Okay, they meet the product owner, they meet the business, they meet the client, the testing team and meets them. They talk about it, they present this specific bug. If they talk about the defect, they talk about pros and cons. They understand if that specific, right, specific defect is going to impact the end user. The impact of that specific bug is discussed. Okay, so let's say the bug that was found, right, in the production, sorry, just before the release, uh, just before the production release, if that issue, if that defect is very critical, if it is going to impact the user, okay, then the team might decide that they will postpone the release. Okay, let's say if the defect is something which is less critical, which is not going to impact the user, then they'll go ahead with the production release, and then they'll plan another release after the production to fix that specific issue. So let's take an example of Gmail. Okay, so the Gmail application, let's assume that Gmail application is about to launch tomorrow. Okay, and I find a defect in the Gmail application wherein I'm not able to send a email to the end user. Okay, so that is something which is a critical defect. Okay, so in that case, what I'll do, right, I'll talk to Google. Okay, I'll talk to them. I'll explain them that this is the defect that we found just now. Okay, and we need to get it fixed because this is a critical issue. And if we launch this specific feature, this specific application with this defect, then all the users will be impacted. Okay, so then there will be discussion on how long will it take to get it fixed. If it is going to be, if they decide, right, if the development team says that it can be fixed in like 5 hours or 6 hours, then the client can ask them to get started working on it and get it fixed before the production release tomorrow. And if they say, right, it will take like 1 week of time, okay, then they'll decide to postpone the release. Instead of like releasing it tomorrow, they'll delay the release date to next week. Okay, so that's how it works. And let's take another example of uh, low severity issue. Okay, so let's take an example of the font size. The Gmail application is about to launch tomorrow. Then the team finds that the font size is different from what is in the requirement. In that case, what happens, right? And the team might, like Google might decide that they want to go ahead with the production release, and maybe they'll create another release a day after tomorrow to fix this specific font size issue. Okay, so it totally depends on the severity of the defect. If it is very critical, then there is a very high chance that the production release is postponed. If the severity is very low, and then it's like they may not postpone the release and they will create another fix for that specific issue, and then they can roll out that fix as part of the next release. Okay, so Kiran is asking which one is first testing, smoke test or sanity? So smoke test is done first and then the sanity check. So sanity testing, in order to make sure that the application can be tested, we do the smoke test, and that is the reason why smoke testing comes first and then the sanity testing. So Manju is saying I am still slightly confused between waterfall and V model. Okay. So Manju, so waterfall and V model, they are totally different. V model is just a framework. Okay, it just shows the relationship between development and testing phase. And waterfall model is totally independent. Okay, so don't try to connect waterfall model with the V model. So think of them as separate. So so V model is not at all related to the waterfall model. Okay, all right. Uh, I'm going through the Q&A section again. Just a second. Okay. All right. So I see like what there was a poll that I had put which asked what is defect clustering. I see like two of the folks answered it incorrectly. So defect clustering is follows the Pareto principle, which says 80% of the defect is found in 20% of the application. Okay. Just make a note of that. And what I would suggest, right, you can WhatsApp me one on one as well in case there is any specific question that you have or something that was unanswered. Feel free to WhatsApp me. You are already part of that group. You can connect with me one on one. You can ping me on WhatsApp. Okay. Or you can make use of the Facebook group, the private Facebook group. You can ask questions there because I'm sure there are many other people who understood those concepts, which might have been difficult for you to understand, right? So they can also answer. They can share their point of view as well in the Facebook group. So either you can ask me one on one, okay, or what you can do is you can put it on the Facebook group as well. And I'm sure like other QA members will definitely help you, and it will be very it will be beneficial for you as well, right? For each one of you, if you guys are helping each other, it will help you learn, understand that topic in a better way. Okay. So with that, I'm ending the day one today. Okay. So what we'll be doing is tomorrow we'll meet at the same time, and then it is going to be a very interesting topic tomorrow, wherein we'll talk about the deliverables and we'll talk about different things that we do as part of the performance testing process. Okay. All right then. Thank you.